Okay, so what will happen by the time micro-P finish ISR, which is after you finish the ISR and the INT0 is still low, means that, okay, you see here, this is your programming. Inside of this programming here, what this programming do is, okay, you press the switch and then you will trigger the interrupt. Okay, once you trigger the interrupt, the interrupt service routine, which is for the INT0 will be executed. Okay, which is kat sini, kalau kita tengok kat sini, this one here, you're going to toggle your port C pin number 3. Okay, the output of port C pin number 3 will be toggle. Okay, so the question here is what happened, okay, by the time the micro-P finish ISR, which is after you finish this ISR here, but okay, the CPU still sense or still detect this INT0's low, means that you still press. Okay, supposedly you release the button, but you still press the switch. Okay, so what happened? Is it will going to do the interrupt again, or dia akan keep monitoring until you press, you press another time? Yang mana satu dia akan buat? Which one it will going to do? Is it will go to do this interrupt, ataupun it will go to monitor until you press again? Okay, anyone? Siapa nak tolong? Okay, another example lah. Okay, something like this. Okay, you have a 8 LED and have 2 subroutine process. Okay, which is process 1 is flashing, and then the process 2 is to count from 1 to 8. Okay, and when switch INT0 is activated, okay, supposedly when INT0 is pressed, okay, so the micro-P will stop from flashing the LED. Okay, your main program is flashing the LED lah. Okay, and then it will go to program B, which is start counting the LED from 1 to 8. Okay, and then after the interrupt is finished, which is you already do the second process, and then supposedly you need to resume the process A lah. But suddenly, okay, the CPU still detects the INT0 masih lagi press on that when it finished doing the interrupt. So what will happen? Apa yang berlaku? Is it you will do the counting 1 to 8 again, or you will do the flashing LED? Mana satu? Okay, so in this case here, it will start counting again. Okay, it will go to your interrupt service routine. Okay, thank you, Josh. Right, so dia akan pergi masuk balik semula lah to your interrupt service routine. Why? Because since the CPU still detect the switch is pressed, even though you finish your interrupt, so it will go to trigger this interrupt again until you release your switch. Okay, so to avoid that, okay, we can use the edge trigger. Means that okay, the interrupt will only trigger whenever it is either a falling edge or rising edge. Means that you tekan sekali ya, you press the switch one, then the interrupt will trigger. Okay, even though you not release the switch, the interrupt will exit and continue with the main program. That is what we are going to see in the next slide by using the edge trigger. Okay, there are 2 types of activation for external hardware interrupt. Okay, the first one here we call it as a level trigger. Okay, so this level trigger is available in INT0 and INT1, and the second one here, okay, we're using the edge trigger. Okay, so this edge trigger only valid in all interrupts, which is INT0, INT1, and INT2. Okay, so in order to what we call here to to activate the edge triggered, so you need to do a programming in 2 registers. Okay, so you need to consider you need to do programming in 2 registers. The first register is we call it as a MCU CSR. Okay, so this MCU CSR indicate whether the INT2 is activated in the falling edge or rising edge. Okay, so kamu ada 2 register that you need to consider lah in order to make it as a falling edge or rising edge triggered. Okay, the first one is for we using the MCU CSR. Okay, so this is for INT2 only lah. Ataupun the second one here we call it as a MCU CR. So this is for INT1 and INT0. Okay, so this MCU CSR, MCU CR is used to activate the edge trigger. Okay. Activate edge trigger. Okay, so let's do this at this MCU CSR. Okay, so the MCU CSR stand for MCU control and status register. Okay, so in this MCU CSR, we are going to focus on the INT2 only, which is either is a falling edge ataupun rising edge. Okay, so the bit that we need to focus here is bit 6. Okay, dekat ISC2 here. Okay, so whenever you put 0, okay, dekat sini, okay, whenever you put a 0 there, in bit 6 here, so this one here, okay, the falling edge of the INT2 will generate the interrupt request, mean that this is a falling edge triggered. Okay, whenever you put 1, okay, in bit 6 here, okay, so this one here means that whenever the rising edge is triggered, okay, the interrupt request will be generated. Okay, so the rest of the value here, you just put 0. Okay, we only focus on the bit 6. Okay, next we have the MCU CR. Okay, so this MCU CR, okay, indicate the trigger option for INT0 and INT1. Okay, so in this MCU CR, we only focus on these 4 bit here. Okay, bit 0, bit 1, bit 2, and bit 3. Okay, so we're going to see this table here. Okay, if you ISC00, ISC01, which is bit 0 and bit 1. This one here is for your INT0, and this one is for INT1. Okay, if you put 00 here, what happens is, okay, the low level of INT0 will generate an interrupt request. Okay, whenever you put 01, okay, you put 01, so any level, any logical change will generate the interrupt request. You put 10, so this is the falling edge, and if you put 11, this is for the rising edge. So every time the signal, okay, is go from low to high, then it will trigger the interrupt request. So this is for the INT0. For the INT1, we need to looking at this bit lah, bit 2 and bit 3, which is dekat ISC10 and ISC11. Okay, same applies, which is 00 is a level trigger, 01 is any logical change, 10 falling edge, and 11 is rising edge. Okay, so this is an example how the interrupt A, okay, to make it as a INT falling edge trigger. B, you're going to make INT1 trigger only on any change, and C, to make INT2 rising edge triggered. Okay, so now we're going to see the A here. Okay, how to make the INT0 falling edge triggered. Okay, for the INT0, you need to remember lah which register that you're going to use for INT0 in order to activate the edge triggered. Okay, so this one is falling edge, so we need to use the MCU CR. Okay, we need to looking at the MCU CR. Okay, for the INT0, the bit that we going to set is dekat sini. Okay, bit 0 and bit 1. Okay, so you know that 0, 0, this is any level. Okay, so this is a level edge triggered. 0, 1, this is, okay, so this is any logical change. 1, 0, what about 1, 0? Falling edge, and when 1, 1, it is a rising edge. Okay, so since this one here, you're going to make it as a falling edge trigger, so you need to put 1, 0 dekat sini. What about the rest of the bit? Okay, the rest of the bit, you just put 0, 0, 0, 0. Okay, so you can program it by writing MCU CR equal to 0B 0, 0, 0, 0 and 0, 0, 1, 0 ataupun 0x0 to in hexadecimal. Okay, if you not going to use this way of programming, okay, you can use the fancy one. Okay, by putting, okay, kat mana kita nak letak satu ni? Okay, by putting 1 to your ISC. What location is here? ISC 0, 1. Pun sama. Okay, so all these things do the same thing. Okay, so this is ISC 01. Okay, to make it as a falling edge trigger. Okay, B. Make INT1 triggered on any change. Okay, so any change means that 0, 1 lah. Okay, so INT1, you need to focus on what bit untuk INT1? Okay, this bit here, dekat sini. Bit 2 and bit 3. Okay, to make it as any change, so you need to put 0, 1 kat sini. The rest, you just put 0. Okay, so you can write MCU CR equal to 0B 0, 0, 0, 0 and then 0, 1, 0, 0. Ataupun MCU CR equal to in hexadecimal. What is the value for the hexadecimals? Anyone can help me? Okay, is it 08 or 04 for hexadecimal? Okay, 0, 4. Okay, and then the third one, okay, make INT2 rising edge trigger. So INT2, we are going to look at what register? MCU CSR register. So at which location that you need to put the value? Okay, bit number 6. Okay, here, which is the ISC 2. Okay, so what number that you're going to put here for the rising edge? Okay, so you know that if you put zeros, this is a falling edge. If you put 1, this is belong to rising edge. So the value that you're going to put is MCU CSR equal to 0B01 00 00. Or, okay, the fancy way to write here is MCU CSR put 1 to your ISC 2 ataupun shift 1 to the location of your ISC 2. Okay, so this is how you're going to activate your falling edge trigger. Okay, so the same examples here. So previously, okay, because we are not okay in this one here, okay, in this what we call, okay, since this one here, okay, you not put any value to your MCU CR, so the MCU CR, the default value is 0x00 lah, which is it will trigger on the whenever it sends logic 0. Okay, so in this case here, you're going to modify so that, okay, this program, okay, only, okay, the interrupt only triggered whenever the int, okay, whenever the int 0 goes low, and then it toggle port C only once. Okay, so for this one, you can use either falling edge or rising edge. Okay, so to do that, okay, you just put here lah. Okay, DDRC. Okay, this is the same thing, same thing. Okay, under the GICR. Okay, before you do the NLB, the SEI, you can put MCU CR. Okay, so this is your edge triggered activation. Okay, you can put in between GICR and SEI. Okay, so in this case here, you're going to make it as a falling edge triggered. So tambah dekat saja dekat sini. Okay, and then if you're going to make it as a rising edge, then the number will be different lah. Okay, so the rising edge, what is the value that you're going to put here for the INT0 rising edge? Anyone? Apa value yang kamu nak kena letak dekat MCU CR for the rising edge? Because this one is falling edge. Okay, you're going to put 1, 1. Okay, so MCUCR equal to 0, B, 0, 0, 0, 0, 0, 0, and 1, 1. Okay, which is equivalent to 0x0. Okay, so any question up until here? Sampai sini ada soalan tak? Okay, so this one here, okay, this why we're going to do to activate the edge trigger, because we're going to make sure that every time you press the switch, okay, the interrupt only occur one time. Okay, that's why we're going to activate the edge trigger. If not, okay, bila kamu hold the when you hold the press, when you hold the switch, sorry, okay, and the interrupt is finished, then what happens is you will trigger another interrupt. Okay, so the interrupt will keep repeating. Why? Because it's sense this low level. Okay, your interrupt only trigger on this low level. Okay, whenever the CPU detect the low level, which is logic 0, then it will trigger the interrupt. So to avoid that, we can use the edge trigger, either it's a rising edge or falling edge. Okay, ada soalan tak? If no soalan, okay, next we are going to go to the next interrupt. Okay, so we have finished the external hardware interrupt, which is interrupt. You have INT0, INT1, and INT2. So you need to make sure lah for the INT0, INT1, INT2, where you're going to put the switches. Is it at the PD2, PD3, or port B pin number 2? Okay, so and this is the things that you need to do lah. Okay, in order to write the interrupt. Okay, first include this header here, and then enable your interrupt. Okay, in between you enable your interrupt, okay, you can activate. Okay, tambah lagi satu kat sini, you can activate your MCU CR ataupun MCU CSR. Okay, to activate either is falling edge or rising edge. Then after that, when you finish, then you do your interrupt service routine. Okay, so you need to follow this step here. Okay, when you follow this step, I'm sure that you can do the interrupt programming. Okay, so next we are going to see the timer interrupt programming. Okay, so basically in Atmega 32, there are 3 timers. Okay, as I mentioned previously, okay, kamu ada 3 timers, which is timer 0, timer 1, and timer 2. Okay, from these 3 timers, sorry. Okay, timer 0 is a 8-bit timer. Timer 2 also 8-bit, but okay, timer 1, this one is a 16-bit timer. Okay, in the next module, we'll focus more on this timer programming, how to write the program. Okay, how to do the calculation and write the program. Okay, there are 2 timer interrupt types. Okay, as I mentioned previously in the previous class, okay, you have the overflow method and compare match timer flag. Okay, so you have two methods here. One is overflow, ataupun sometimes we call it as a normal mode. And the second one here is compare match, which is a CTC mode. Okay, this mode here is different lah. Okay, from one to another. Okay, the way you do the calculation, the way you do the programming, it are different. Okay, between normal mode and CTC mode. Okay, and then timer 0 and timer 2 are 8-bit, while timer 1 is 16-bit wide. Okay, if the timer interrupt in the interrupt register is enabled, okay, so the timer overflow flags, okay, which is TOVX is raised. Okay, whenever the timer rolls over and the micro P jumps to the interrupt vector to service the ISR. Okay, so it depends lah. Either you use the CTC mode or overflow mode. Okay, so whenever the timer flag is raised, then the CPU know that you're going to do interrupt. Okay, so to enable the timer interrupt for a given timer, okay, you must set the TOIEX bit that held by the TIMSK register. Okay, so this is your TIFR. Okay, you have 2 register actually. Okay, TIFR, which is used to see the flags. Okay, either it's a raise or not, and TIMSK register is used to enable the timer register. Okay, if you're going to enable the timer 0 overflow methods, then you need to enable this bit here. Okay, if you're going to use the timer 1 overflow method, then you need to enable at this bit here. Okay, if you're going to use the timer 2 overflow method, then you're going to enable dekat this bit and inside of your TIMSK. Okay, and then this for the overflow method. Okay, so for the timer 0, okay, you're going to monitor this flags here dekat TOV0. Okay, which is this is an overflow for timer 0 flags inside of your TIFR register. Okay, and then for the timer 1, we need to monitor the TOV1 flags, and timer 2 need to monitor the TOV2 flags. Okay, so to enable the timer interrupt, okay, let's say you're going to use the timer 0, so you can write as follow. Okay, TIMSK, okay, and then shift 1 to the timer 0 overflow method. Okay, and then after that, followed by SEI. Okay, again. So this is your TIMSK. Okay, so kena ingat lah. Okay, you need to know lah the what we call here, the position of each of this bit here. Okay, so this one here belong to timer 0 overflow. This is a timer 0 compare mesh CTC mode ataupun CTC mode. This is a timer 1 overflow, and this is a timer 1 compare mesh, And this one is timer to overflow method, and here is a timer to compare mesh method. So you need to enable at this dekat bit kat sini. Okay, depending on the timer interrupt that you're going to use. Okay, so let's look at example here. Okay, write a program to A, enable the timer 0 overflow interrupt. Okay, so how to do that? Okay, you can put TIMSK and then equal to 1. Okay, shift 1 to this location. Timer 0 overflow interrupt. TOIE 0. So you need to make sure the label here is correct lah. If not, then it will be wrong. Ataupun, okay, to be safe, okay, just write down TIMSK equal to 0B00001. Why you put 1 dekat belakang ni? Because the timer 0, okay, overflow method is at a bit 0 kat sini. Okay, that's why we need to put 1 at our TIMSK in order to enable timer 0 overflow method. Okay, and then B, disable. Okay, so you're going to disable. Okay, disable mask the timer 0 overflow interrupt. So how to disable? Okay, you can use the TIMSK equal to 0B, put 0 lah. Okay, whenever you put 0, then what happens is you're going to disable your interrupt. Ataupun you can disable it globally by use the CLI. Okay, clear your I interrupt inside of your status registers. So this is how to disable interrupt globally. Okay, and I see show how to disable all the interrupt with a single instruction. Okay, so this is how to disable all interrupt with a single instruction. Just put a CLI. Okay, any question up until here? Ada soalan tak? Okay, if no question, then we're going to see the example. Okay, kita nak tengok example. Okay, so this program use timer 0 to generate a square wave on pin port B5 while at the same time data is being transferred from port C to port D. Okay, so now you have two tasks here. Okay, satu to generate a square wave at port B, pin number 5. And the second one here is to transfer a data from port C to this port D. Okay, so first what you're going to do is you need to identify lah which task or which program is belong to your interrupt. Okay, so in this case here, okay, to generate a square wave is your interrupt. Okay, under your interrupt service routine. Why? To send the data, to transfer the data from port C to port D. So this is your main program. Okay, so identify. So this one here to generate a square wave. So this is your ISR, under your ISR. While to transfer here to here, so this is under your main program. Okay, and then how to write the program? Okay, so to write the program, okay, the first step that you're going to use to do is for timer 1, for what we call here, to write an interrupt using a timer. Okay, so first sama jugalah. Okay, include avr/interrupt dot h. Okay, make sure that you include this file here. Okay, so this is your first step. Okay, the second step, okay, you need to enable your interrupt. Dekat mana nak enable interrupt? You have two locations that you're going to enable. Okay, first is at your TIMSK, and the second one here at your status register. Okay, by using the SKEE instruction. Okay, and then, okay, step number 4. Okay, this is step number 4. Okay, you need to make your timer. Sorry, not step number 4, step number 3. Okay, so this is a timer setting. Okay, so make sure that you do all the timer setting. And then the last step here, step number 4 barulah, followed by your ISR. Okay, doing your interrupt service routine. Okay, so you have a additional step lah compared to external hardware interrupt, which is you need to do the timer setting at step number 3. Okay, so this using a timer. This is using external hardware. Okay, so let's look at this. Okay, so let's look at this timer interrupt programming. Okay, so you're going to do an interrupt, which is this interrupt here. Okay, so the interrupt will occur whenever, okay, by using the timer 0, which is it will generate a square wave, and then for the main program, okay, you're going to send the value from port C to your port D. So how to write the program? Okay, first, okay, so this one, this is your first step. Okay, so include the interrupt.h file as well as any header. Okay, so this one here, okay, this is the default lah. Okay, you need to make sure that you include avr/io.h as well as your interrupt header. Okay, so this is your step number 1. Okay, and then you start with your main program. Okay, so I just write in the here inside of the white box here. Okay, so first include avr/io.hash, and then include avr/interrupt .h. Okay, so I lukis semula. Okay, so this is PB5. Okay, so this PB5 here to generate a square wave, while you have a port C. Okay, so this is 8-bit lah. Okay, switches. This is port C, and this is your port D. And then you have the LEDs. So this is also 8-bit. Okay, so this is your first step. Okay, include the header, interrupt header. And then after you include the interrupt header, what you're going to do next is you write down your main program lah. So this is your main program, int main void. Okay, so inside of this int main void, so first what you're going to do inside of your int main void kat sini. Okay, you need to initialize lah this port here. Okay, which one belong to input port, which one belong to output port. So in this case here, port D is your output. Okay, so this is your output. Port C, since this is your switch, So this one become input. What about PB5, port B pin number 5? Is it output or input? Okay, so output as well because you're going to produce a square wave. Okay, so this one also output. Okay, so you just write down DDRD sama dengan OXFF and then DDRB. Okay, so since port B5 here, okay, so you can make all the port B5, port B as an output pun boleh. Okay, so you just put 0xFF as well. And then port C, DDRC equal to 0. Why 0? Because D is your input. Okay, so since your port C connected to your switch, then what you're going to do next? Apa kena nak buat pula dekat port C ni? Okay, make sure that you enable your pull up resistor. Okay, because this one here connected to switch. Okay, make sure that you enable pull up resistor. How to enable pull up resistor? Port C sama dengan 0x FF. Okay, next. Okay, so you already initialize your program, your input output ports. So next, what you're going to do? Then the second step should follow down here lah. Okay, which is you need to enable, okay, your TIMSK as well as your status register. Okay, so TIMSK equal to, okay, so since this one here, okay, you're going to use the timer 0 and then overflow method. Okay, so you need to know lah inside of your TIMSK. So this is your TIMSK. Where is a timer 0 overflow method, which is dekat bit 0. Okay, so you need to put 1 here. Okay, so TIMSK equal to 0B00000001. Okay, so here, Hao Ang asking that, okay, the question requires only port PB5 as output, but we can set the whole DDRB as output. Also, yes, you can set the whole DDRB as an output because if you can see here, okay, the port B here, there is no mixed input and output. So you can set all the output, no problem. Okay, if the port B, you have the mixed input and output, then you need to make sure lah, okay, which bit belong to input and which bit belong to your output. Okay, if not, you just set all the port as an input or output. Okay, then TIMSK. Once you've done that, okay, then you need to enable your global your IFET dekat status register. So by putting SEI. Okay, so this is a step number 2. And then step number 3. Okay, so this step number 3, I need to go to my slide. Okay, so this is your step number 3, which is you're going to do the timer setting. Okay, so here, this timer setting here, we will cover in the next module. Okay, so we just leave this timer setting, how to calculate this one, how to put the TSC T0 with this value, and how to put the timer setting dekat TCCR0. I assume that this, okay, I assume that this one is wrong lah because this is a negative 32. Okay, you cannot put the negative 32 inside of your TC and T0. Okay, so this value is wrong actually. Okay, so this timer setting we will cover in the next module. Okay, so timer setting. So just put the timer setting here. And then after that, once you done the timer setting, then you need to do your while loop lah. Okay, so while 1. Kenapa while 1? Because you're going to, if you see here, Okay, so this, okay, you will read the switches from port C and send it to your port D. So this one here will be done forever. Okay, so whenever the input coming from your switches will be sent to your port D. So while one, so what we're going to do down here is port D equal to pin C. So whatever value inside your pin C will go to your port D. Okay, and then you close curly bracket and you close your main program. And then after that, we're going to do our, so this is our main program, and step number 4. Okay, so I just put here, this is your step number 4. Okay, step number 4 is your interrupt service routine. Okay, your ISR. Okay, so ISR, okay, you do your interrupt service routine. And what is your ISR name? Okay, make sure that the name is correct. Okay, how to know the ISR name? By looking at the vector table. Okay, dekat sini. Okay, you refer to this vector table here. Okay, so timer 0, where is I? Okay, so timer 0 overflow. So timer 0 underscore OVF underscore vet. Okay, so that's why. Okay, here, okay, you see here timer 0 underscore OVF underscore vet. So this is the ISR for timer 0 overflow. And then, okay, then you need to do the setting again lah. Okay, set the timer again. And okay, so this is another timer setting to set. Okay, I just write down here. ISR underscore OVF underscore vet. Okay, and then inside here, okay, you can, because you're going to toggle your port B pin number 5, right? So port B, okay, you just put port B sama dengan, okay, port B, okay, exclusive all kan with 0B0010 and then followed by 0000, because we are focusing on this bit only. Okay, so you just put port B equal to port B exclusive all this. So this one here to do toggle. Okay, once done that, okay, then you need to start your timer again lah. Okay, so this start timer again. Yes, so how to start timer again? By put the TCNT 0 value. Okay, so put lah your TCNT 0 with the value. Okay, the calculation value. This is how you're going to start your timer. Sini. Alright. Okay, Josh asking here. Okay, the ISR exit when the TCNT overflow? No, no, Josh. Okay, the ISR exit. Okay, mana saya punya tadi? Okay, from here lah. Okay, so this ISR exit once it finish do this thing here. Mana tadi? Oh, sorry, not this one. Okay, yang ni. Okay, once it's finished do this thing. Okay, this one here, and then the ISR will exit it. Okay, once this exit, so the CPU will monitor the TOV0 flags. Okay, when when it raise again, it will go to the ISR. Okay. Okay, so this one program timer interrupt, but this one by using the compare mesh timer flag. Okay, sometimes a task should be done periodically. Okay, so if you use the rollover overflow, okay, we cannot do it periodically. Okay, means that it will do it once only, unless you put the setting inside here, then it will do it periodically. But by using a compare mesh, it will automatic done periodically. Okay, so the program can be written using the CTC mode and compare. Okay, and then use the OCF flag to 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 see lah whether the timer the interrupt is triggered or not. Previously, we look at the TOB flag. For the CTC mode, we use the OCF flag. Okay, so to do so, okay, you're going to load the OCR register with the proper value and initialize the number of the CTC mode. And when the content of your TCNT matches with the OCR, the OCF flag is set, which cause the compare interrupt to occur. Okay, it's something like this lah. So this is your OCR punya value, and then this is your TCNT. Okay, so you put a value to your TCNT. Okay, whenever the OCR equal to your TCNT value, and then the flag here will trigger. Okay, flag akan naik. Okay, will be raised. Okay, when the flag is raised, so the CPU know that you're going to trigger your timer. Okay, and then after it exit the ISR, the interrupt service routine, so the flag will automatically put 0, okay, give 0, okay, will because this one here, okay, when the OCR equal to TCNT, the OCF flag will go high. So when it finish the ISR, so the OCF flag will be cleared, okay, will become 0, and then the OCR will counting again until it equal to your TCNT, and then this flag here, the OCF flag will raise once more. Okay, so this will done periodically. Okay, so dia akan buat according to what delay that you are creating here. Okay, depending on your delay that you are creating. Okay, so let's look at this example here. Okay, you are going to use a timer 0, write a program that toggle pin port B5 every 40 microsecond, while at the same time transferring data from port C to the port D. Okay, similar to what we did earlier, sama dengan yang ini, tapi this one here we using the overflow method, but now we are going to change this one. Okay, instead of using the overflow method, you're going to use the CTC method. Okay, sama juga lah, follow the step. Okay, this is your first step, and then this is your main program. So inside of your main program, you initialize your input-output port. When you already initialize your input-output port, then you need to enable your interrupt. Okay, so this is a TIMSK. Okay, put 1 to your OCIE 0 because this is timer 0 CTC mode. Okay, so you need to enable at this location lah. Ataupun, okay, you can write TIMSK sama dengan 0B 00000010. So this is your OCIE 0 location. Okay, similar. And then you enable your interrupt globally. Okay, and then this is your timer setting, which is your step number 3. Okay, so this timer setting here we will learn in the next module. Okay, so how to calculate the OCR value, how to make this setting here. Okay, you will learn in the next module. Okay, and then this one here, while one port D equal to port C, so sama lah. So whatever you press from your switch will be displayed on your port C. So this will be done forever lah. Okay, and then once the interrupt is triggered, okay, by using a timer, so make sure that the timer here is correct lah. Okay, the ISR name here is correct, which is timer 0 underscore com underscore back. Okay, so make sure the name is correct. Okay, and inside here, okay, you see you toggle your port B pin number 5. Okay, so it will be done periodically. So any question? Ada soalan tak up until here? Okay, so for this one here, for the timer, untuk yang step number 3 ni kita akan buat in the next module. Okay, all the calculation will be done in the next module. Yes, the TCNT, okay, for this one here, untuk yang ni, case yang ni, TCNT value is remain. You see, this is your TCNT. Oh, I'm sorry. Okay, when the TCNT equal to OCR, okay, and then what happened here? Okay, so in this case here, the TCNT will automatically reset. Okay, contohlah kalau kamu letak kat sini OCR sama dengan 200. Okay, so the TCNT will started at 0 and will increase until it equal to 200. Okay, when TCNT equal to 200, which is equal to your OCR, so what happened? The OCF will raise. Okay, and then once it finish here, okay, bila dia dah masuk sini, once it's finished, the TCNT will be reset so that it will come 0 again. Okay, Kennex still don't understand how will enter the ISR and exit. Okay, contohlah this one here, Kennex. Okay, let's this one here. Okay, saya lukis lah. Let's the delay here. Sorry. Contohlah, this is 5 microsecond. Okay, contoh this is a 4 microsecond. Is it 4 or 40? 4 microseconds, eh? Okay, so what happened here is, okay, so every 4 microseconds, so you will go to this interrupt service routine, which is you're going to do the square wave. Okay, so now, okay, so first, okay, the port B value here, let's say like your port B now is 0. Okay, this is your started of your port B lah. Okay, so port B, okay, PB5, okay, the value here is 0, the initial value. Okay, so 0. Okay, once you do this setting, okay, so once the CPU run this setting here, so the TCNT value will increase. Okay, contohlah here. Okay, so this is your OCR. Okay, you put it at 40. Okay, and then this is your TCNT. Okay, so the TCNT is starting from 0 and it will keep increase. Okay, to generate a 4 milliseconds. Okay, so what happened here is, okay, so this one here, okay, PV0 will display 0. Okay, at the same time here, your TCNT value will increase from 0 until, okay, 40. Okay, now your TCNT 0 is 14. So what happened here is OCF flags equal to 1. Okay, when the OCF flags equal to 1, okay, so what happened? The CPU now will trigger your interrupt service routine. Okay, when the OCF equal to 1, okay, interrupt ISR is triggered. ISR triggered. So apa yang berlaku? So it will go down here, and then your port B here, okay, your port B value is 0. Okay, the current value is 0. So what happen here is will become toggle. Jadi 1. Okay, so this one here, this is your 4 microseconds. Okay, since this one here, okay, once dia dah masuk sini, so port B become 0, and then the counter here will start increase again. Okay, the TCNT is reset to 0, and it will increase again until, okay, it reach 40. Okay, so this value here dekat PB5 will produce 1 until OCF here equal to 1, which is your OCR equal to TCNT, then the OCF equal to 1. So what happened here? ISR is triggered again. So it will go to here, and then inside here you see, oh, we need to toggle again. So it will become toggle. So this is another 4 microseconds, and it will keep repeating. All right? Is it clear? So this is how the timer interrupt occurs. Okay, so when the OCF equal to 1, then what happened to your is TCNT? Okay, the TCNT will be reset when the interrupt the what we call that? Okay, the TCNT will stop. Okay, once the ISR is run. Okay, and then when it is finished, okay, it exit here, the TCNT will be reset. Yes, the OCF will go back to 0. Yes, correct. Okay, whenever you finish here, you finish the ISR. So this one here, your OCF automatically will be reset to 0. Betul. Okay, so now, okay, for this one here, because we using a timer interrupt, so no need to use the external interrupt. Okay, kalau kamu pakai timer interrupt, no need to use the what we call it, external interrupt. Unless, okay, you're going to use both internal and timer interrupt at the same time, then you need to enable both lah. Okay, so in this programming, no. In this example, no need to use the external interrupt. Okay, any other questions? If no question, then we go to interrupt priority and interrupt inside interrupt. Can you do interrupt inside interrupt, which is when you trigger an interrupt A, can you trigger interrupt B at the same time? Okay, we're going to see that. Okay, so what will happen when 2 interrupts are activated at the same time? Okay, which one will respond first? Okay, so in this case here, we are going to look at the interrupt priority. So macam mana nak tengok interrupt priority? By looking at interrupt vector table. Okay, so for example if 2 interrupts are activated at the same time, the interrupt with the higher priority will be served first. Okay, so the priority of interrupt is related to the address of the interrupt in the interrupt vector table. Okay, for example, you have interrupt 1 and interrupt 2. Okay, when you press both interrupt at the same time, so the interrupt 0 will be invoked, will be triggered. Why? Because the interrupt 0 has higher priority compared to interrupt 2. Okay, for example, you have an int 0 and then you have a timer 0 overflow method, okay, triggered at the same time. So which one will be triggered? So of course lah, the int 0. Okay, so the external hardware interrupt has higher priority compared to timer interrupt. Okay, so this is what happen lah when both interrupt is triggered at the same time. Which one will be responded? Okay, based on the interrupt vector table. Okay, next, what happen if AVR is executing an ISR belonging to an interrupt and another interrupt is activated? Means that you currently do interrupt A, but at the middle of the interrupt A, you're going to do another interrupt. Can you do that? Okay, the answer is cannot. Why cannot? Okay, so when AVR begins to execute an ISR, okay, it will disable the I bit in the status register. Okay, when you disable I bit in status register means that you disable all the interrupt globally. Okay, so there is no interrupt can happen. Okay, causing all the interrupt to be disabled, those no other interrupt occur while service the interrupt. Okay, and when RETI is executed, means that if after you finish the interrupt service routine, what happened here? The AVR, okay, the CPU will enable the I bit in the status register. Okay, so the CPU will automatically enable the I bit inside the status register, causing the other interrupt to be served. So inside interrupt cannot happen. Okay, it is impossible to happen. Okay, because of this reason here. Okay, any question? So I think we finish our interrupt programming. Kita dah habis kita punya interrupt programming. So now, okay, we're going to do some examples here. Okay, so I give you a 5-minute breaks, and then after that we continue with this example. Okay, boleh ya? Port C, okay, you are going to use a timer 0 to generate a delay of 100 milliseconds. Two external interrupt on INT0 and INT1 will be used to choose the blinking pattern. Okay, so INT0 will generate a pattern 1. Okay, so you just write down lah. So this one here. Okay, this pattern 1 will be triggered by INT1. And okay, sorry, this is INT0 and pattern 2 will be triggered by INT1. Okay, so the CPU frequency is 1 megahertz. So based on this information, write your program. Okay, so first, what are you going to do? Apa kita nak buat? Okay, so in this case here, okay, you draw lah your AVR. Okay, and it says that 8 LEDs are connected to port C. So let's lah, this is your port C. And then you connect it to your LED lah. Ada 8 LEDs. Okay, so it's a 8-bit LEDs. And then, what about this one here? INT0 and INT1. Dekat mana kita nak letak? So INT0 and INT1 actually at your PD2 and PD3. Okay, so PD3. So this is INT0 and INT1. Okay, so this is the lukisan that you can draw from information given inside of this question. Now we are going to write the program. Okay, so I draw again. Okay, kamu ada this one here. This is your AVR. And then this is your LEDs, which is you have an 8-bit LED connect to your port C, and then PD2 and PD disambung pada you punya switches. Okay, interrupt switches. Okay, so first, what are you going to do? Okay, so in this case here, okay, so first thing first, okay, we include all the header file, okay, to make this what we call this interrupt programming lah. Okay, first is hashtag include avr/io.h, and then you need to include, okay, since this is a interrupt programming, so you need to, this is the first step lah, include the avr/interrupt dot h. Okay, next. Okay, you can define lah. Okay, because it says that the CPU is 1 megahertz, so just define f underscore CPU equal to 1 megahertz. Okay, and then to generate a delay, okay, so in this case here, okay, we just use the delay function, okay, that available inside of the C programming, because this question not asking you to calculate the delay, okay, to generate a delay using a timer 0, timer 1. So in this case, we just use the delay that are predefined in the library, okay, by using the include avr/delay dot h. Okay, so this is your first step. Okay, next, followed by, next you're going to do your main program lah, int main void. So inside of this main program, what are you going to do? Okay, mula-mula kita nak buat apa ni inside of this main program? Okay, initialize your input output port. Okay, so since this one is port C connected to LED, so DDRC equal to 0x FF. So port C become output port. What about port D? Okay, so port D, you can make all the port D here as your input port. Okay, so DDRD equal to 0, which is all the port D as a input port. Okay, and then because this one here, port D is connected to switches, so you need to enable your pull-up resistor. Okay, so how to enable pull-up resistor? By writing port D equal to 0x F. Okay, so this one here, okay, kalau tak nak tulis macam ni pun, you can write another way, which is you can write something like this, DDRC, and then put 1, okay, to PD2, and then all-kan dengan put 1 to your PD3, and satu lagi, okay, you need to put a bracket here, followed by tilde. Okay, means that you inverted, okay, because this one is shift 1 to PD2, shift 1 to PD3, and when you put the inverted, what happened is, so now instead of putting 1, now you putting 0 dekat PD2 and PD3, so that your PD2 and PD3 become input ports. Okay. Is the f underscore CPU always 1 megahertz? It depends on the question. Okay. If the question says that the Esther speed or the CPU speed is 4 megahertz, then you need to define lah your f underscore CPU equal to 4 million. Okay. It will depend on the question. Okay. Sometimes 1 megahertz, sometimes it's 8 megahertz, sometimes it's 4 megahertz. Okay. Depending on the question. Okay, once you already initialize, okay, then the step two, what the step two, what you're going to do? Okay, because this is the external hardware interrupt. Okay, we're using the INT0 and INT1. So step two, apa yang kamu kena buat for the step two? Okay, you need to enable lah your interrupt. Okay, so enable your interrupt. Dekat mana nak enable? Dekat GICR. Okay, enable your interrupt at at GICR 0B. Okay, so GICR, recall back your GICR, which bit that you need to enable. Okay, so this is INT 1, this is INT 0, and this is INT 2. Okay, so you need to put enable dekat INT 1 and INT 2, INT 0, which is at bit 6 and bit 7. Okay, the rest of the bit you just put 0 lah. Okay, so GICR equal to 0B11000000. Or the fancy way to write this one here is GICR sama dengan okay, shift 1 to INT1 location and OR kan dengan shift 1 to INT0 location also can. Okay, this is all. Okay, once you did this one, okay, then what you're going to do? Step number 2. This is your step number 2. Okay, bila kita dah enable GICR, and then you need to enable SEI. Okay, so SEI down here. Okay, in between. Okay, in between, we are going to set our MCU CR. Okay, so MCU CR. Okay, in this question, is it asking you rising edge or negative edge trigger? Ada tak dia beritahu? Okay, no. So we can choose either falling edge or rising edge. Okay, so 0B0000, and then 1111. This is for rising edge for INT0 and INT1. Okay, so step number 2 and 3 are already done here. And then your program lah, okay. While 1. Okay, what you going to write in this while loop here? Ada apa-apa tak kita nak tulis dalam while loop according to this question? Okay, nothing. So you just monitor je lah. Okay, you just waiting until the interrupt is triggered. Okay, and then you finish your main program. Okay. Okay, so this you close the main program, and then step number 3, we are going to write our interrupt service routine. Okay, our ISR. Okay, so in this question here, we have 2 ISR. Okay, one is for INT0 and the other one for the INT1. So we do the ISR0 dulu. So ISR. Okay, so make sure that the name is correct lah. INT0 underscore get and open clear bracket, close clear bracket down here. Okay, so what you're going to do for the ISR INT0? Do this sequence lah. Okay, whenever the INT0 is triggered, okay, you're going to do this sequence here, which is blinking the LED. Okay, so port C. Okay, so this one is port C because LED is connected to port C equal to, okay, first all the LED will be turned on. Okay, since this one here you see kita guna common apa ni? What common we are using here? Common or common catet? Okay, we are using the common catet. Okay, so for common catet to turn on, you need to give 0. If you give 1, turn on, give 1, give 0, then it will off. Okay, so make sure that the first value here is 0B1111 1111. Okay, and then call a delay. Okay, what is your delay? 100 milliseconds. So by using this delay function here, so you just write down underscore delay underscore ms, okay, and then you put 100 lah for 100 millisecond. Okay, and then the second sequence here is port C. Okay, delay 100. Okay, if you write delay 100, then it's wrong lah. Unless, okay, there is unless down here, what you write down delay 100 and then equal to underscore delay underscore ms 100, then it will correct. Okay, so it if you're going to use a delay 100 or sleep 100, it depending on the library that you're going to what we call here to include inside of this program. Okay, if that library, okay, provided this delay 100 and sleep 100, then you can use. If not, you cannot use lah. And if you use, then what happens is when you run, when you compile, the error will occur. The syntax error will occur. Okay, if you have the library to include which support this sleep 100 and delay 100, so why not you use that? Okay, so this one here is kosong B. Okay, just write down kosong 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 kosong, and then call it delay underscore ms 100 and close curly bracket. Okay, so this for the ISR for INT0. Okay, what about the INT1? So now you're going to look this lah for the tulis lah for INT1. Okay, make the ISR INT1 underscore back. Okay, so down here, what you're going to program? Okay, depending on this pattern lah. Okay, so mana tadi? Okay, this pattern here. Okay, so this LED turn on, and then after that, these two LED until LED 6 and LED 7 turn on. Okay, so we just write down port C sama dengan 0B00000011 and then call a delay. Okay, so this is for the sequence 1, and then sequence 2, port C sama dengan 0B. What happened here? 00 1100. Okay, you can finish it by your own, yeah, because this one is keep blinking now. Okay, boleh ya? Until port C underscore 0B 11000000 and call the delay. All right, so this is our program. Okay, to do this to do to display this pattern. Okay, that are requested by this client shop. Okay, so any question? If no question, I think we can stop here. Okay, and Wednesday kita akan buat another examples. So